Welcome to the Convergence Podcast. I'm your host, Ashok Shivanan.
For all of the many great and wonderful things that large language models have kind of brought to our everyday lives, they frequently make mistakes. It's really a direct and also very simple attack vector.
On this show, we'll deconstruct the best practices, principles, and the underlying philosophies behind the most engaged product teams who ship the most successful products. This is what teams are made of. AI coding assistants are no doubt speeding up development, and vibe coding is enabling folks to make applications even if they don't necessarily have a ton of prior production software experience. But they may also be introducing security vulnerabilities into your network. AI models are suggesting hallucinated software package names, ones that don't actually exist. Yet, these hallucinated packages can be easily registered by attackers and loaded with malware. And once one of your engineers install this on their device, they have access to your company network. Welcome back to another episode of Convergence.fm, folks. In this episode, I get to speak with Joe Spracklen. Joe is a U.S. Army cybersecurity officer and also a PhD researcher whose recent study reveals how these package hallucinations could pose a threat to companies adopting LLMs in their software engineering workflows. Now, whether your team is experimenting with AI coding assistants or pasting code directly from ChatGPT or another LLM, this conversation unpacks the hidden risks and what tech leaders like yourself need to consider as you lead your teams to adopting coding assistants into your software development process. At the end of the episode, I also share a synthesis of advice from some of my peers who run really large engineering teams and how they go about mitigating against this threat. Subscribe to the podcast to get future episodes as soon as they're published. If you find this helpful, give the podcast a 5-star rating on your podcast app or hit that like button on YouTube. Here's my conversation with Joe Spracklen. Congratulations on your paper being accepted. As folks in the corporate world, or I say in industry, are using LLMs more and more so with helping with software development, concerns around security and privacy are definitely top of mind. And understanding different vectors and different mitigations are subsequently something that people are thinking about. So what was the initial hypothesis that y'all set out with in your study?
So the initial hypothesis was pretty easy to come up with, right? Because it had happened to me. It was a kind of a firsthand experience. So we knew, and also talking with other researchers, they had experienced these package hallucinations themselves as well. So we were confident, and we had this anecdotal evidence that this was going to happen, and we were confident we were going to be able to generate these package hallucinations, kind of in a controlled environment. But we needed to do that kind of rigorous, comprehensive, experimental validation. So our first goal was to prove that these hallucinations happen across a wide variety of models and a wide variety of settings, and to really characterize how often they happen, and then learn more about them to help the greater research field understand what leads to them, what causes them, and to help us understand how we can potentially mitigate or reduce them from happening in the wild. So I think maybe just to be clear, I should probably lay out what exactly the research was, and that and what exactly the vulnerability is. So if you code a lot, and our study was specifically on Python and JavaScript, you almost certainly need what we call packages or libraries to help augment your programming language. And what these packages and libraries do is give your programming language additional capabilities to accomplish other tasks that you might need to do. It's common for any project to have hundreds to even thousands of packages or libraries in your local environment just to help your code do what it is you want to do, right?
These are typically open source libraries that you'd be downloading.
Exactly, right. And Python and JavaScript represent the two largest ecosystems of open source packages and libraries. I believe Python has around 500,000 packages, and JavaScript has, I think, 5 million packages. So these are huge ecosystems, and they've been built up over, I mean, in JavaScript, decades, and Python, well, I guess decades as well. But the key there is that they are open source. That means anyone can contribute a package without verification anonymously, and they can put whatever code they want inside the package, right? So that opens a huge attack vector for malicious actors to potentially plant malware in these packages and load them up to these open source repositories where then anyone can download and install them. And that itself has been around for a long time. Bad actors realize quickly that that's a great way to try to get people to download malware. The hard part was always tricking them into downloading the wrong package. So these package hallucinations are just kind of the latest generation way to trick users into downloading a package that they don't mean to, and that's through exploiting what we're calling a package hallucination. And so for all of the many great and wonderful things that large language models have kind of brought to our everyday lives, it's well known that they frequently make mistakes, and we generally call those mistakes hallucinations. Hallucinations specifically refer to when a model invents or generates a fact that is not true or completely fictitious. It is not factually correct. So in this case, it occurs when you ask a large language model to generate code for you. We found that a large percentage of the time, it will recommend for you or generate a package to use with your code that doesn't actually exist. The package is not present on one of the open source repositories. Now, normally this wouldn't seem like a big deal. If you try to install a package that doesn't exist, it just errors out, and no harm, no foul. But we thought, with an adversarial mindset, what if an attacker proactively registered a package name under one of these hallucinated package names? They would have to figure out which names are hallucinated. If they proactively register a package with that name that's laced with malware, and now your unsuspecting user who's just trying to, maybe they copy and paste the code direct from the LLM, and this gets even more relevant with the recent rise of vibe coding, right? Where you get people who maybe aren't familiar with coding, and they might just copy and paste it into their environment, and that's going to automatically fetch that code. And if that package has malware in it, then you've just infected your entire machine, and that could extend to infecting an entire code base. If you work at a larger company, it can infect your entire network. If you're at a larger organization, it's really a direct and also very simple attack vector.
Yeah, and generally when we download these packages, they also have really high levels of permission on your device that enable any bad actors with those high levels of permission, for example, executing software while being on your corporate network. And so that's a high level of authority now we're providing to someone outside through this approach. So I can see why, from a bad actor standpoint, it's a really viable way to carry out malicious activity.
You are giving them the keys of the castle. So it reveals a weak point in our software supply chain, because you're placing a ton of implicit trust on the authors of these packages that the code that they have put in this open source repository is legitimate and useful and benign, right? So many of the most popular packages you can trust just kind of from the masses. They're so popular and they're used by so many people that you can generally trust that their content is legitimate. And that takes a little bit of due diligence. Maybe if there's a package you haven't heard of, you have to go do some research. You look at their GitHub page, you look at their README file, you look at, hey, is this a reputable author? Who's making this package? You do a little deep dive before you download it. And the most popular packages are well known and common, but when you start to get some of the more obscure packages for more not so well known tasks, you start to get in a bit of uncharted territory.
Fostering an engaged product organization and aligning them with the principles around lean, human-centered design, and agile will more than likely lead to successful business outcomes for your organization. But getting started or getting unblocked can be hard. This podcast is brought to you by the player coaches over at Integral. They help ambitious companies like you build amazing product teams and ship products in artificial intelligence, cloud, web, and mobile. Listeners to the podcast can head on over to integral.io/convergence and get a free product success lab. During this session, the Integral team will facilitate a problem-solving exercise that gives you clarity and confidence to solve a product, design, or engineering problem. That's integral.io/convergence. Now, back to the show.
Threats like package squatting have existed for quite a while. And it's valuable because if you're able to convince this developer to download a package that they think is a safe one and is actually malicious, when they download it to include as part of their overall software, they give it access to being able to run an executable or an application on their device. So not only does it have access to whatever's on their device, oftentimes these devices are connected to some kind of corporate network. And so it has access to data and information that's available across everything that's now on this corporate network. And so I'm curious about a couple of things in terms of understanding how big of a problem or how concerned we need to be. And one of them that comes up is like, hey, what models did you test? And the second one is, how often is it likely to give me the same hallucinated package name so that it's something that someone may have gone through the effort of creating a malicious package with the same name? So maybe start us with which models were tested and which ones had the problems.
So we wanted to test the best models available, from both open source and commercial models. So we tested 3 different ChatGPT models, as well as Code Llama, DeepSeek models. Those are the popular open source models. We tested a few different parameter levels as well. So we tested, for example, 4 different DeepSeek models between 1 billion, 7 billion, 32 billion parameters, and the same with the Code Llama. So a wide variety of size and type of models tested. And our big finding there was that these package hallucinations occurred across all models tested at some significant percentage. The commercial models did much better. The average for the ChatGPT series was about 5% hallucination rate, compared to the open source, which was much higher at 20% averaged across all models. So you do get a little bit more bang for your buck if you go commercial, but still 5% is still a pretty large number.
And then the second piece, I think, is, in order for this bad actor to be successful, it has to provide the same hallucinated package name that it provided to that bad actor when they were trying to do something. So they know what name is a hallucinated name that when I'm writing maybe similar code, it's likely to suggest to me when I would go download that package, right? So in terms of hallucinations, what's the likelihood that it would spit out a similar hallucinated package name?
Yeah, exactly. So the second big key finding we found in our research was that these hallucinations are persistent, which again, as you mentioned, provides a much better attack vector for malicious actors, because if these hallucinations were simply one-off random errors and it never happened again, then there would be no way for malicious actors to plant their malware in these hallucinated package names, because no one else would ever use them. But what we found is, in the experiment we ran, was when we found a prompt that generated a hallucinated package name, we would simply repeat that same prompt 10 times. And then we would just count, of those 10 times, how often was that package name regenerated by the same model. And we found that 45% of the time it occurred all 10 iterations. So every time the same package was regenerated, which is significant. So that means that these hallucinations are persistent. They aren't simply random one-off errors. There is some reason or cause within the models that's making them continually surface again and again. So you could reasonably say that for two people asking the same coding question of an LLM, you could reasonably say it's about a 50% chance that those hallucinated package names would be generated for both users asking the same question.
And so there's a reasonable chance that if I create a packet, if I am a bad actor and I notice that it hallucinated, there's a 50% chance that someone else asking that question is going to get the same, or prompting that question is going to get the same hallucinated package, and thereby creating a vulnerability in the system. If I create a malicious package with that hallucinated name. So, wow, man. Well, appreciate you coming on here and sharing with us what your findings are. I think this is early days in this industry, and folks are still on the rise with adopting LLMs to assist with coding, and also adopt the various mitigation practices so that security and privacy continue to be top of mind as we work within sensitive networks on sensitive topics and with sensitive data. A couple of questions that I like to ask all the guests that come on, since we're really focused here in helping our audience with fostering engaged teams that build delightful products. Of course, security is a big concern around being able to be delightful to your customers. What is a team that you really admire or aspire towards? And this could be fictional or real. It doesn't have to be a team that you've been on yourself.
I think I'd be a little remiss here if I didn't talk about the Army in terms of being kind of the ultimate team. And I hope this doesn't come off as too maybe starry-eyed or idealized, but I really think the military unit is kind of the ultimate team. I think there's just not too many places where, especially outside of sports, where people come together in pursuit of, a common goal. It's not motivated by money and just motivated by something maybe bigger than yourself. I haven't experienced life on the outside of the military, but I know a lot of people that have, and the people that I do talk to that have gotten out say they do miss kind of the bonds and the camaraderie they had while they were inside the military. So, of course, life might be better in other ways, but I do admire teams that they have a great culture. They're driven by a shared purpose. And I've seen that a lot in the military, but I know it exists outside as well. And I think that's something that really great leaders will be able to cultivate and create that culture, whether it's in the military or the private sector. But that's hopefully doesn't come off as too big of a plug for the Army. But that is one of the things, and one of the reasons I've stayed in for so long is I do enjoy the bonds and the kind of the shared purpose.
And then the other thing that we like to talk about here a lot, other than teams, is the products that those teams built. So I'm curious whether it's a product or a service that you recently unboxed or experienced, something that recently just blew your socks off and you're like, wow, this team who built it, they just really get it.
I'm a big Whoop fan.
Yeah, I got one of them here as well.
Okay, all right.
Tell me more about what you like about it.
Well, for one, it just works, right? All the time. You never have to think about what it's doing. It's always on and it's always working well. I love the app. The app's so clean and simple and easy to navigate and intuitive. And to me, it's just kind of the gold standard of a kind of an app product synergy that's valuable and just works.
Yeah, for sure. Getting hardware and software to talk to each other seamlessly is hard enough. And then given how often the folks at Whoop seem to be able to update their app as well as to update the software that sits on the device and have not all of it just brick and black out has been pretty amazing. If folks are more curious about your research or to nerd out a little bit more, what's the best way for folks to get a hold of you?
I'm on LinkedIn, just Joe Spracklen. And then I think, you're welcome to email me at my school email, it would be joseph.spracklen at my.utsa.edu.
Awesome. We'll make sure to have both of those in the show notes. Thank you so much for making time and educating us around some of the threats that exist around the cybersecurity side of using LLMs to write code.
Thanks so much for having me. It's always a pleasure to talk about my research. I appreciate it.
Hope you enjoyed that take from Joe. Certainly a few concerns that he raised there. Now, software supply chain attacks aren't new, and they have caused real damage in the past. For example, in 2016, the sudden removal of a tiny NPM package called LeftPad broke thousands of apps across the JavaScript ecosystem, including major frameworks like React. This wasn't even a malicious intent, I understand, and yet had pretty major implications. A few years later, attackers slipped malware into the popular event stream package by taking over maintenance of the open source libraries and ended up targeting a Bitcoin wallet app. And a few years later, in 2021, a malicious version of UA Parser.js, a package that had over 8 million weekly downloads, was pushed to NPM and started stealing credentials and crypto wallets within hours. So if you're a seasoned developer or your team has mature practices, this hopefully isn't the first time that you're hearing about package management and how serious of a concern that it can be. But we gotta concede, things are different now. With the rise of AI coding assistants and vibe coding, there are more people writing production software or installing these packages on their devices that are on your production network. Often these folks may not have strong security backgrounds, yet their work computers have the same security clearance as the ones that your mature developers do. That means vulnerabilities that used to be rare could be more common as these new threats and threat vectors emerge. So I spoke to a few folks who lead major software teams, and there were 4 things that tended to come up in almost all the conversations that I had. First, they restrict installs to trusted sources. So you're less likely to download a hallucinated package in the first place. They use internal allow list tools like pip constraints files for Python or NPM's access controls for JavaScript. And what it does is it makes sure that your team isn't pulling in random packages without a review. As an aside, developers are going to want ones that aren't on your allow list. And I would ensure that the security leaders or engineering leaders that maintain the allow list respond pretty quickly to vet the new requests and approve or reject them so that you maintain speed while also being secure. Second, they monitor their dependencies. Tools like Snyk, socket.dev, and Phylum can flag new or low reputation packages. And those are the kinds that most likely to be hallucinated or hijacked before someone actually installs them onto their device or into production. Third, they don't let developers pull libraries straight from the public internet. They instead use private proxies like Artifactory or Nexus and inspect and mirror only approved packages inside your environment. And you can also integrate these into your CI/CD pipelines. And finally, investing in developer awareness more than before. Especially now with non-traditional engineers entering the field, we need to build a strong culture around secure habits. And as AI coding assistants are powerful, they also hallucinate. And when they do, it's your supply chain and your customers' data that end up being at risk. Hope those mitigations are helpful for you and you can put them into play relatively soon if you haven't already. Thank you for listening to this episode of Convergence.fm. We'll be back again next week with another episode around fostering engaged teams who ship delightful products. We'll see you then. Thank you for joining me on the Convergence Podcast today. Subscribe to the Convergence Podcast on Apple Podcast, Spotify, YouTube, or wherever you get your content. If you're listening and found this helpful, please give us a 5-star review. And if you're watching on YouTube, hit that like button and tell me what you think about what you heard today.